Hey everyone, let me first introduce myself. I'm Mitali. I head the AI labs at Versa Innovation. The product that I'm working on is Josh. Josh is a short video platform. I think you would have heard of Instagram Reels and Chingari app. So, Josh is something that was built in India for Indians basically who are native language speakers when TikTok got banned in India, and we have seen a lot of growth in short video space in the last couple of years. So that's what I primarily do over here. I have a team that works a lot on video analysis, video segmentation, and recommendation, retrieval, ranking, blending, and all such stuff, which is required to improvise the feed for the users. I have been working in this space of AI for close to a decade now. After doing my master's from IIIT Bangalore, where my major was in data science. So since then, I have worked for larger organizations as well as startups, working in IC role, contributing to data science, as well as leading and developing and uh, basically driving data science as a charter for these startups. So that's a bit about me. We can get started. Today, the agenda is to talk a little bit about video segmentation. I'm going to touch up at a very high level what video segmentation means, because the kinds of algorithms that are available in this space is sort of endless, right? And I think if you guys want, or if you would want to connect with me separately and want to dig deeper into a couple of topics, feel free to do that. But for today, we are going to keep it at a very high level. I will talk about what video segmentation actually means, right? Where the use cases or applications are in the current world scenario. Then I can also talk about uh, analysis of this short video space, right? How short video space works, what kind of analysis or algorithms or deep learning practices we use in this space to serve the best videos to the users in a short video platform. So that's a bit about the agenda. I think, Siddharth, are we going to take questions at the end, or it's a sort of an interactive session?
Mitali, it's based upon your preference. If you want to stop in middle and if you want to ask, let people ask questions, it's okay. Or if you want to keep it at last, we could ask participants to put it on chat, or they can unmute themselves like after the talk, and then they could ask the questions. So whatever you feel would
Okay,
work for you.
sounds good. We can keep it a little bit hybrid, and I would always prefer a little bit more interaction from everybody. So, is everybody clear on the agenda? I think we can get started now. Okay, I'll start sharing my screen quickly. So, this talk, as I mentioned, is about video segmentation and video processing. So, what exactly is video segmentation, right? So, when we hear the word video segmentation, so anybody who wants to talk about what comes to their mind when they hear video segmentation, anybody who wants to pitch in and answer that question?
Folks, you could unmute yourself and speak. It's okay.
Okay. Yeah, that's a pretty fair answer. So basically, video segmentation is mostly about finding objects, right? For finding the region of interest or finding the focus areas in the videos that are present, right? Correct. I think Sanjay, you are on the right track over here. So two large areas of video segmentation are foreground and background region detection, right? And second is object tracking. So what happens in foreground and background region detection is, let's say you want one object that is of interest to you, and you would want to track that across the entire video. So let's say if somebody is dancing, and but that is one person who is of interest to you, and anything that is uh, around that person or is there as a part of surrounding, we would want to remove that, and we would just want to focus on the person who is dancing. So that kind of basically application is called foreground and background region detection, and there are multiple algorithms that are used for doing that. Second is object tracking. So of course, here a different kind of features come into play, which are mostly optical flow features. So what happens in this is that, let's say you have a car or a vehicle or anything that is in motion, right? And you would want to track that across your entire video, that where this object is continuously moving. That is called object tracking. This is heavily used in a lot of use cases like surveillance or in CCTV videos and so on. Now, let's talk about the techniques that are being used for this. So, very basic one is unsupervised video segmentation, and second one is semi-supervised video object segmentation. Let me talk a little bit about what unsupervised and semi-supervised video object segmentation means. So unsupervised, when we talk about unsupervised video object segmentation or anything that is unsupervised in nature, what comes to your mind? Anything that you would want to share? Anything that you would have heard about what is unsupervised in any use case, any application? Anybody? Okay. Anybody else? Okay, I got one response, I think, which is clustering. Anybody else? Okay, clustering is one of the applications of unsupervised uh, techniques. So basically, whenever there is no human input required, right, uh, that is called an unsupervised technique. For example, let's say a very classic case of use case or application in data science is uh, classification, right? So let's say you have various animals, cat, dog, horse, and you would want your model to tell you, given a new picture of the animal, that which animal it is, whether it's a cat, it's a dog, it's something else, right? So how would you tell your model, how would you train your model to learn this? What you do is you prepare a training data which is labeled, where you tell, given this image, this is the image of a horse, given the second image, this is the image of a cat, right? So that is where you are already giving input to it, and you are giving some sort of learning to the model, teaching the model to learn this, pick this, and then apply this for something that it has not seen before. In unsupervised techniques, we cannot give any of those inputs. It has to learn on its own. It has to learn, or it has to pick, or it has to detect the patterns on its own. So, detecting the pattern is actually what is done in clustering. So, where you have, let's say, you have a population, right? A human population of India, let's say. There are people, and this population is represented by people. People could be from North India, people could be from South India, people could be somebody who like to eat sweets. There could be people who like to eat salty food. There could be like people of one gender, then the people of another gender. Then how do you group them? Right? And these are all features about those humans. How do you group them? When the algorithm looks at these features and tries to put them into certain buckets, that is what is called as clustering. Here you are not giving any input, that given that this is the kind of feature available, this is what the class is going to be of the person. So I hope this is a little bit clear about what is unsupervised and supervised. Anybody who has any questions on this? Okay, I will go ahead then. So, Unsupervised video object segmentation, when we talk about this, how unsupervised techniques are used in video segmentation is what I'm going to tell over here. So, for example, you have a video of a person walking, right? And this is when you look at this input stream, this is a CCTV captured video. And you can see multiple frames are there. I think one, two, three, four. If you count, there are four frames that are represented over here. The person is walking. They cross this path from right side to the left side. We need to detect that whether the person was present in this frame or not. What do we do in that case? We want to detect our object or the person that we are interested in. Very simple unsupervised methods mean you find a background, right? Because background is something which is static, it's not changing. You have put a CCTV camera there, the background remains same there. But what will change is the people or the moving objects that come in front of it. So what you do is you have a background model which tells you that this is the background image. You do a background subtraction from the input stream that you get, and then you finally get the person or the region of interest. You apply certain thresholds which basically tell you whether this is noise or not a noise, right? There can be pixels that could be noisy as well. So this is one of the very, very, very basic techniques that is used. Uh, in this case, like there are other basic techniques also that are used. I can verbally talk about them. So here it is simple. You take a pixel level data, you subtract it with the background model, and whatever you finally get is basically your object of interest. And you can do masking and all of that. Basically, covering all of this with black is masking. Where you want to, whatever is not of interest to you, you just mask it black or paint it black or paint it white or paint it of some other color, whatever you want, right? So that is what unsupervised, one of the unsupervised methods is. Another one could be, so let's say you have multiple pixels over here, and the pixels can carry multiple information across different frames. One could be about the RGB values, the other one could be about spatial features. Spatial is what is present in frames in terms of space, x and y coordinates. Then the other information could be about temporal features, which are about like the objects flowing in the frame. And then what you do is you cluster them. Clustering is also, as I explained, an unsupervised way. So once you cluster them, you finally get a cluster which actually has information of the moving object, and the rest of them, which were static, are grouped separately. You can always remove them and keep the one that was of interest to you. That is how some of the unsupervised video object segmentation techniques work. Obviously, these are quite naive in nature. They are pretty old, right? These are classic ones that have been in use since many years. In recent times, a lot of improvements, a lot of research has been done in this space. So we have neural network based approaches, transformer based approaches. We have a lot of new ways in which we can do object segmentation now. Should I move on to the next one, where I can explain a little bit about semi-supervised video object segmentation techniques? Anybody, any questions? Yes, please go ahead, tell me. Is the yes for go ahead or for asking a question?
I think it's for go ahead. You can
Okay.
continue.
Okay, sounds good. Yeah, please raise your hand or drop in a message whenever you have a question. I will just take a pause there. Okay, semi-supervised video object segmentation techniques. Anybody who has any idea about transformers here? Okay, can you tell me what do you mean by that? It's okay, feel free to unmute yourself and talk. There is nothing wrong or right answer, everything is correct. Right, attention is all you need. That's a very classic paper.
Hello, can you
Yes.
hear me? Yeah. Sorry for not admitting myself. So, if we see about transformer,
Mm-hmm.
uh, this was released in 2019. I guess the attention is all new.
Mm-hmm.
Uh, but the entire attention technique was formulated in 2017. I guess I'm
Okay.
really bad at histories, so let's not focus on this. The simple self-attention techniques recently made this world into a growing one in the AI industry. Like if you see ChatGPT or any large language models, or if you come across generative AIs like DALI and Midjourney and everything, they are basically using this transformer. This enriches the world about huge impact of uh, builded AI, generative AI with transformers. So the core idea behind this transformer is self-attention, which is based on three matrices, key query values.
Mm-hmm.
So shall I go ahead and explain about key query or just
Yeah,
explain?
you can go ahead and explain. I think it would be nice to hear.
So okay, what happens inside key self-attention is let's go ahead and simply learn like this. Query is nothing but if you are searching something in LinkedIn, key are those the values you are getting as a result.
Mm-hmm.
Uh, then values is later what we are watching. That's
Okay.
how I interpret. But this is a simple way to explain. But if you want to go to technically, it starts with the dot product.
Mm-hmm.
We are actually calculate attention score and multiply with every other matrices in order to produce in order to connect a single word to every other words.
Okay.
Mm, not certain word. Okay, a single feature to every other feature in the matrix.
Mm-hmm.
So that's how it calculates the attention for each word. Like how much importance should I give to this feature?
Mm-hmm. Okay. Sounds good. I think that was very well explained, Sanjay. You want to add something else?
No, I'm, I'm really bad at explanation. Sorry.
No worries. It was quite good, actually. Yeah. So basically, I think you already mentioned that in one of the lines without going into a lot of technical depth of how this is happening. Basically, attention model tells you that what is the importance of one of the words or features or basically component for the rest other ones, right? So that is where you get to know that, let's say, for example, very basic example, data science is a word, right? And then there is another word where it is written as that this data is processed. The kind of importance the word data will have for data science together will be different than what data will have as a word for data is being processed, right? So these kind of attention mechanisms are captured by these attention models. This is it's a complex architecture where you do some matrix multiplication, you do some lookup tables, you have key query value pairs, there is an encoder block, there is a decoder block. So basically it tries to transform all your features into one space, and then using those space, what you could do is you could use it for different training tasks. So that is where attention heads come into play. Wo- the input that goes in semi-supervised video object segmentation is the spatiotemporal features, self-attention features, which have basically a sparse connectivity. To talk about in very simple terms, I would say that the spatio-temporal features consists of, like, again, the features that I told some time back, which could be your RGB values, the pixel values at a given position, right? Where positional encoding comes into play as well. Then also about, like, certain optic features, like how the pixels or the a given pixel is being value is being moved across frames. All these features go into input, and then finally you pass it to a transformer block. So a lot of research, a lot of papers are coming in this space, which are basically zero shot attention based, one shot attention based, even for motion detection. So without going into too much details, because it's going to get very, very complicated otherwise, I think we one of the papers is has recently come, I think few years back, which is on one shot video object segmentation as well, which in if you just give single frame, it is able to tell you that what is the kind of object that you are trying to detect through that. So that is how semi-supervised video object segmentation works. It could also use CNN. It could also use transformers. Basically, anything that gives you embeddings and transforms this data into some other space. Okay, I think moving on, if you don't have any questions. What are the use cases of video segmentation in the current space? I think the hackathon is going on, which is more towards surveillance and in that space. But there are different areas, different fields also where video segmentation, video processing, and motion detection is being used. One of the biggest use case these days is video editing, right? So if you see, there are a lot of AI tools that are coming in where, let's say, there is a video and you want to remove the background from the entire video, and the person who you are interested to keep in that video must be there, but that person doesn't stay static. Let's say the person is, it's a wedding video, for example. So the people who you are interested in, bride and groom, they will not just keep sitting static in one place, right, throughout the length of the video. And you have, let's say, a 10-second clip of them dancing, but you want to remove the other people who are in the background. So that is one of the use cases. It could be used in video editing, where you find who is your person of interest and then you remove others, you mask them, or you could even masking is making them, painting them with one single color, or you could even use another methods, which is like merging with the background. So whatever the neighboring pixels are, you could even cover that with them. I will tell you another example which I personally worked on, right? It was an e-commerce space while I was working at one of the startups. So where we had models in this catalog. So at Amazon, I think all of you must have purchased some t-shirts, some kurtas, saris, or something like that, right? All of us have done that kind of purchase through Amazon. But if you see, right, and if you want to detect what is the, and you are building an algorithm which needs to detect what kind of clothing the person is wearing, and you have to just detect it from the images. You can't use the text for it. How would you do? Because the person could be in any posture. The person might be standing with their hands crossed in front, or they are posing somewhere, or they are standing straight. It could be anything, right? So one of the use cases was to get the entire t-shirt picture and remove the hands that are coming in front of it. How would you do that? You know that this is the person that you are interested in. For hands removal, you would try to merge it with the background. Now here in this case, the background is the t-shirt that the person is wearing, and you remove that skin color with the boundaries of the other pixels that are there next to the hand. So that is actually one of the biggest use cases that is used in all these e-commerce organizations or any company that works in that space. So yeah, second one is surveillance. Surveillance, obviously, you want to track somebody, right? Even for uh, security forces, for border forces. Let's say you have a drone or you have CCTV cameras or somebody uh, like which is capturing pictures of sensitive areas, and you want to know if there is any movement happening in that space. I think this is a very good example where uh, video segmentation could be used. Third is sports analysis, obviously, like to know ball tracking when that becomes your object of interest, or the motion of the sports person, right? So all these things, I mean, are very much, all these techniques play a very big role over there. Any questions so far? Okay, I will move on then. Yeah. So I was talking about sports. I think all of us know that for ball tracking and all of that, and um, basically tracking the behavior or the uh, uh, to improve the player performance and to make to help the coaches make better decisions, all of this could be used. Then comes entertainment space. In entertainment, basically, it can be more about like you detect if the person is talking or not, if a given person is there in the frame or not, what are the people who are present, what kind of captions you can generate for them. You can actually train a model, a separate model, which can detect people and also the text that they are speaking. And then you can try to train a model which is on text and video pair. So there are models that are available. That's a separate space altogether, which we would probably need a separate session to talk about. But yeah, it can be heavily used in entertainment space as well. Then transportation, obviously, like you want to track a vehicle that is moving, right? Or maybe you have a drone that is capturing a video of a maybe person who is going in a vehicle, and you want to keep tracking that car, right? Or in maybe highways, patrolling, and all of those areas, this could be used. So there are a lot of use cases. I think I have just mentioned very few of them, but a lot of spaces where actually this video segmentation could be of use. Okay, I think if we are good over here, I would want to take a pause because now next, if the time permits and if people are interested, I could even talk about the use cases of video analysis, video processing, and what kind of techniques we use for short video platforms for the feed recommendation. Siddharth, what do you suggest?
Yeah, Mitali, we can pause for a minute. Like, anybody has any questions? Okay. If you find it difficult to unmute and speak, you could put it on chat also. Okay. So maybe I'll rephrase my question this way. Do you want to like Mitali to like walk us over the analysis part? How many of you are interested in like understanding how video analysis work? Yeah, Sanjay. Is that hand rose for like? Do you want to know about it?
Okay, sounds good. I think I'll continue then. So before jumping to that, because I have not prepared a lot of detailed slides on that part, it's more about verbal explanation. And since we have been doing that day in, day out at Josh, so yeah, it's almost on my tips now. Okay, so when you let me make it very interactive because I think all of you have used Instagram Reels, right? I'm hoping you have used Reels or YouTube Shorts or any other short video platform, or maybe TikTok, or maybe in fact Josh, if you would have used it, or Chingari. I think all of you are aware of it.
Yes.
Okay. Okay. So, how do you think that, let's say, when you're watching food videos, suddenly you start seeing only food videos, right? Or let's say you're watching some travel videos, and in the next session, when you open, you start getting more of travel videos or status messages. They start coming in the morning only or at night, good morning messages. Have we all observed that, this kind of behavior? Yeah, okay. I think even if one of you writes yes, I can just go ahead. Oh, yeah. I tried. Okay. Yeah, we don't do that, but maybe yes, some of the apps do it. Okay. Yeah, sounds good. So I think we all know that somehow through some techniques, through some algorithms, these apps, in fact, not just short video apps, but e commerce apps like Amazon, Flipkart, right, are able to capture our interests. We see products that we are interested in, we see videos that we are interested in, we see on YouTube the larger videos that we are interested in. If you are using Netflix, Amazon Prime, anything like that, it suggests you videos that you might be interested in. So somebody is able to capture your interests, right? And then out of all the millions of items that are there, millions of videos that are there, it is able to still pick up the top 3, 4, 5 items that you might be interested in. And more often it happens that you actually tend to really like them. Either you watch it completely, you'll hit a like there, or you actually share it with somebody, right? All of that engagement happens. We all have done that, we all have observed that. So how does that happen actually? What is the core fundamental of it? So it is a very, very extensive journey. Like, I think this is the most interesting part. I think nobody would have even thought about it. Even to be very honest, before I joined um, in this particular space, before I joined, before I had started working with Josh, even I was not aware that there could be so many detailed algorithms, there could be so many nice techniques that could be used, and so much work that goes behind serving you that one video which you are interested in. So just bear with me. Yeah, I'm sure you are going to enjoy the next 5-10 minutes for sure. Okay, so what happens is, it's a big funnel, right? You understand funnel, that it starts with something big and then it keeps on reducing, and then you are basically left with few items. So it starts with a very big funnel. There are a lot of foundational things that are done on videos to understand first what the video is about, right? So a video could be about food. Let's say a video could be about a celebrity. A video could be about uh, maybe travel. A video could be about anything. How do we know that what kind of category this video is representing? And since we are not aware that totally how many categories can exist, can you tell me that how many total themes can exist in the world of the types of videos? In how many genres are there in YouTube? Can anybody tell me that? I don't think so, right? It's a very tough question. If you say, let's say somebody says, yeah, there are 10 genres. One could be food, travel, or animals, pets, things like that. But can we really say that for sure? No, right? Because in food also, you can have something which is maybe biryani, there could be puri sabzi, there could be dosa, there could be sambar, different food categories. So, I mean, it's very tough to actually say that in total in the world, there can be only X types of videos or X types of categories that can exist. Then how do we understand that if we don't even know the count, how do we know that what this video is about? That's where it becomes tricky. And if you don't know what it is about, how would you even suggest that to a user? How would you even capture their interest? So, first thing, very, very foundational step, I'll move to the next slide now, is to get the embeddings, right? So, embeddings is basically, you all know what are embeddings? Anybody who doesn't know what embeddings is? Or who would want to tell me what embeddings are? Anybody? Okay. Embeddings is basically, yeah, I will explain embeddings. Embeddings is basically a feature vector. It's a vector. It could be of any dimension. It could be of 16 dimensions, 32 dimensions, 128 dimensions. It's a vector. So if you are a Python user, basically, so it's a list. So let's say a list has these items 0.9, 0.1, uh, 4.2, and so on, right? I've just written that in the chat messages. So it's a list of different values. The size of the list could be anything. It could be 16, 32, 128, 256, 1024, whatever. What does this list represent? It is a representation of a video. It could be a representation of an image also. It could be representation of an audio also. Basically, embeddings are feature vectors that capture the essence, or that captures the entire information about the object that we are trying to get this data on. It could be anything. So in our case, an embeddings is a feature vector or a informative like vector array which represents a video. So when we have to process videos, we don't see them as videos which are playing, right? It is a feature vector. This is the kind of embeddings that we have. So we have a vector that has different values, and each value represent a different feature about it. One could be about its maybe the color component. Second one could be about its what kind of objects are there. All of that is represented in form of numbers and stored in the form of a array. And the array size could be depending on like how big you want, how much more information you would want to capture about a video. Obviously something that is captured in 4 5 vectors only is is not going to be so much informative. uh, Rather, if you capture something which is the length of 1024 or bigger than that, will have more information. I will explain that with a very simple example, because I think that most of you don't know about embeddings. So, for example, again, let me go back to the human population example. There are people who are from India. Indians could be from a region. Indians could be about a caste also. Like if you talk about me, I am if I'm an Indian, one information about me is which city I belong to, which caste I belong to, what is my color, what is my height, how does my hair look like, right? Or what kind of food I like, what kind of languages I speak, right? Whether I'm a male or female, it's everything, every information about me. If you categorize these information, if you put that, let's say I'm talking about 1,000 different aspects about me, it becomes a 1,000 length vector or a 1,000 length array, where each value represents one feature about me. Now, how do we get to numbers for these? I mean, you can have different ways to get that. I think if I go into that, it will be very, very tricky to explain. But I hope you understood what embeddings mean now. Is it clear? Can I move on? Okay, good. So when we try to get embeddings, right? How do we get that for a use case like videos? Now there are a lot of ways to do that. There are like convoluted like CNNs that are there. There are basically basic algorithms that are there. There are transformers that are there. What you do is, let's say when you are training a model on some kind of data, for example, that pet categorization example, right? Whether it is cat, dog, horse, what kind of a pet it is. When you train a model, rather than taking the output that whether which category it belongs to, you take data from one of the previous layers, which has all the information about you, about your input data point. And that is how you can get embeddings in a simple CNN. I think given the audience, like probably it would need a deeper session, I think, to explain and to go into deeper concepts. But I hope you are trying to get a very high level view. So basically, we get embeddings or feature representations for videos. What these videos mean, the way I explained about human population in my example, different features. Once you have that embedding, what do you do with that? Right? That is a video for you. Now, forget about the video that is being played. You get one embeddings, which is a representation of your video. How do we move from there to actually feed ranking, where you get a personalized video on your feed? Next step is you cluster those embeddings, right? Clustering is basically anything that has a similar kind of pattern is put into one group. I think it is represented in very simple diagram on the bottom. So when you cluster it, you actually get that these videos are similar in nature. So everything that is food related will come into one cluster. Everything which is travel related will come into another cluster. And this clustering is done on your feature vector only, the embeddings that you have. So it will just try to group it basis the similarity. So basically, in my kind of example, probably what will happen if your feature is very dominant about what kind of state you come from and what kind of food preferences you have, it will basically club maybe people coming from Uttar Pradesh in one group, and who are also vegetarians probably, and who are also have a liking for sweet. So this kind of small clusters will be formed, which will become one theme for you. So in my case, or in Josh's case, what will happen? Anything that is travel related, food related, or let's say religion related, or let's say status messages related, these kind of videos will form their own niche pockets. Once we have these clusters, we know that users, let's say when they watch certain content, right, they have certain kind of affinity or liking towards one kind of cluster. That they are watching a lot of content from food, then they are watching a lot of content from travel, then they are watching a lot of content from maybe pets, dogs or cats. What happens is, uh, while trying to recommend the next video that they should watch, we pick certain candidates from each of these clusters. Let's say they have watched uh, dosa video. Maybe they will be also interested in idli, which is also an item which is similar to dosa because it falls in the same category. And if they are watching, let's say, uh, Leh Ladakh videos, right? Maybe they will also be interested in Spiti videos, which is also a hill station in Himachal. It's similar kind of terrain, right? So when you try to get similar candidates from each of these clusters, what you do is you take up all these candidates, you combine them, and then you finally pass it to a ranker. Ranker will basically rank them or sort them basis the past history of the users. They will take the history that, okay, which cluster they had more affinity towards, what they watched more, right, what similar kind of users watched more, and then they will rank them. Once the ranking has been done or sorting has been done, we take the top candidates and serve it to the users. I have tried to explain at a very high level, but basically there are a lot of details that go into this. But hopefully this will give you some idea of about how the videos are being processed, what kind of information is being captured about them, how we make clusters or categories of them, and then finally we rank them, and then it goes to the user's feed or the kind of videos that they see on their app. Any questions on this? I think that's more or less uh, everything from my end. I can take up questions now or try to conclude it.